Okay, case 3. Yes, I am always confused. Here we have a point, external point again, and we have a tangent line. It only touches the circle at one point and then continues to travel on past. All right, a tangent line. So that's just one length there, and then on the other side we have a secant line that has the two pieces. All right, well, just like in case 2, we're going to have to take on this side the whole line times the outside piece. There's the whole line, x plus z plus y, times the outside case. And the other side, we're going to set equal to that length there squared. All right, so we're going to square that length. So let me move on to an example. Where's our example for that one? Okay, let's just find one here because apparently I don't have my example page here right at the moment. Right here, problem number 7 in the practice is just like that. And I'm going to jot down quickly what it is I have to multiply. The whole line times the outside equals other side, I'll just say the tangent line squared. Okay, so, all right. So we got an x there on the tangent, and we have a 10 and an 8. So we have x squared equals 10 plus 8, that's our whole line, times 8. So x squared is 18 times 8, x squared is 144. And I don't want x squared, I want x, so I need to square root everything. So I square rooted everything there. X equals 12. All right, you want to double check? 12 times 12 equals 8 times 18. 144 equals 144. We good. All right, so in this case 3, I also want to point out to you on these two pieces. These two problems are kind of a step up. There's step 1 in difficulty. This is step 2 in difficulty levels. All right, because notice you're going to have, okay, Mrs. Nielsen can't read either. You're going to have this whole line and this line, and this should be a 6. Okay, none of my students have caught me yet on that. They should have. And this will change this to a 12 distribution, okay, because this is x plus 6, and I have to add it to 2. Oh, that's why my 8 was there. Okay, never mind. Okay, 6 plus 2 is 8, duh. Okay, so we're backtracking here. 2x plus 16, I was correct the first time around, and so x is 10. Again, if I want to check that, that means 36 is equal to 16 times 2. Is that right? No, 18 times 2, 36. All right. So that was just a slight step increase in difficulty. This one, okay, I made a mistake the first time through. I was talking with a student. I thought we had to use quadratic formula. And nope, not that difficult. All right, so let me grab a piece of paper here. Dun, 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 dun. Okay, let's see if I got a clean copy of this. I do. I do not. Okay. So, oh, there's my case 3 piece, but that's all right. Okay, so right here, I'm going to copy this problem down. Okay, got me a circle, exterior point, and a tangent. L, okay, this is x plus 2, and this one is 12 from there to there. Okay. So we have on this side, we have x plus 2 plus x, that's the whole length of that line, times x equals 12 squared. Okay, so that's where we're at. This is 144. And over here, this is 2x plus 2. And again, we have to multiply by x. I'm going to move the x in front. I can do that with the commutative property because I'm just more comfortable seeing it in front. Less likely to forget what I'm supposed to do. All right, so this is x times 2x squared, plus 2x. And I'm going to move the 144 over by subtraction. So I know on this side it's negative 144 equals 0. Okay. So that looks a little harder than the last one. It is one slight step harder. I notice these are all even numbers. So I'm going to divide everything by 2. 2. Okay, so that leaves me with x squared plus x minus 72 equals 0. Okay, 0 divided by 2 is 0, so that 2 just goes away. All right, this is going to factor. I need a number that multiplies to negative 72 and adds to positive 1. That's, you say to yourself, well, how's that going to happen? All right, well, again, I know my start is x, because that's how I get the x squared. Okay, so numbers that multiply by 72. Well, maybe you didn't know this, but any two-digit number that adds to 9 is something that can be, that means 9 is a factor, or I can divide evenly by 9. And I happen to know that 9 times 8 is 72. Okay, the nines table is actually quite easy if anyone has ever taught you that, but I find that's usually not the case. Okay, so I know I need the bigger number positive because I got a positive there. So I got x plus 9, x minus 8. I know when I add these two numbers together, it will be just a positive 1, which is what that is right there, a 1. That equals 0, so this means that x is negative 9 and x equals positive 8, because again, I had to take x plus 9 equals 0, and I had to subtract 9. That's where the negative 9, that's where the sign change comes from. Okay, so if I were in Algebra 2 and I were asked to tell the teacher where this crosses the x-axis, I would say it crosses at negative 9 and positive 8, Mrs. Flock. Okay, or whoever your algebra teacher will be. All right, you do that, wham, she's going to go, wow, you know what you're doing. And by the way, it's going to cross the y-axis at negative 72. So how bright are you on that one? All right, so anyway, but we're in the world of geometry, so the only positive here is x equal 8. That means our x has to be equal to 8. So we have then 10 there, 8 there. Let's see. Let me figure this out. 8 plus 2. Aha. Okay, I always mess this up. 8 plus 2 plus 8 times 8. All right, 10, 18, that's 18 times 8, and that is equal to 144, and we know that's also equal to 12 squared. Bam, done, checked, go. All right, go for it, people. Have fun, enjoy. It's actually kind of cool. And check your answer against my checked answers that are already posted. See ya. Bye-bye.